All right, so we're going to work out number 2 now. So there's a bunch of questions that look just like this throughout the assignment, so hopefully you'll use this to help you. So whenever the question is asking to find the energy, you have to look at what information is given. So again, the first step is always to choose your formula. So we have 3 formulas, just like before. So the speed of light is equal to wavelength times frequency. Energy is equal to Planck's constant times frequency. And the third one was energy is equal to Planck's constant times the speed of light over wavelength. So you need to pick the formula that matches the information. So clearly, this question is asking about energy. So automatically, this equation has nothing to do with energy, so we're not using it. We have to choose one of these. Now, hopefully, we can use the easier one, but let's make sure we have the frequency, because in order to use this equation, you need the frequency. If we don't have the frequency, we're going to have to use the wavelength, and then we have to use this one. Okay, but let's just check. So the question is number 1. So here's number 1. In question number 1, they gave me wavelength, but we also calculated the frequency. See, the frequency was right here. So because we know the frequency, I can actually use the easier equation. We got lucky. All right, let's do the math. So energy is equal to Planck's constant. In the notes that I gave you guys, you should see, you should see that Planck's constant is always going to be 6.626 times 10 to the negative 34th joules times seconds. So we're going to take that number and just write it in. All right. And there we go. All right, so energy is equal to Planck's constant. And I always tell you guys to put this in parentheses so that you know all of this represents the H. And it was joules times seconds. And then the frequency, we also know. So the frequency was right here. So I'm just going to take this number and put it here. Let's make it bigger. All right, so this is 10 to the positive 14. So the unit for frequency here was hertz. Hopefully you guys remember hertz is the same thing as an inverse second, which is second to the negative 1, which is the same thing. Anytime you have a negative exponent, that means that it goes in the denominator. So this one is the one that I'm going to use, and I'll show you why. So 1/seconds is my unit. Right. So at this point, I wanted to show you that seconds is in the numerator over here, and seconds is in the denominator over here. So because we have numerator and denominator, they cancel. That's why I like to use this version, because you can clearly see how the units cancel. And what I'm left with is joules, and that's good because you're supposed to have joules. That is the unit of energy. Now that I know my units all match up, I'm going to go ahead and do the math. So in your calculator, you can just put this all in. So parentheses 6.626 times 10 to the power of negative 34 multiplied by parentheses 7.5 times 10 to the power of 14. You might be asking why I didn't include this 0. So the 0 at the end isn't going to make a difference, but if you included it, not a big deal. All right, so that equals 4.969. So let's check for sig figs. In this number, there are 4 sig figs. In this number, there are 3 sig figs. So my answer should also have 3 sig figs. So 1, 2, 3. I'm going to round up because 9 is greater than 5. So it should be 4.97 times 10 to the negative 19. So 4.97, let's make this bigger, times 10 to the negative 19. And that unit, again, was joules, because that's the only thing that's left over. So, and that should be the answer for number 2. Hopefully you can use that to solve other equations that are similar.